Thank you for that very generous introduction. I hope everybody is thinking of the mystery that we are about to unravel. Good morning, everybody. We can move to the next slide, please. I assume that everybody was thinking what can be really mysterious in nuclear and why is nuclear mysterious. I have a few points here, but primarily, many things in nuclear science and technology is not so well known. Oftentimes, fear is associated with anything nuclear. You mention the word nuclear, and immediately the reaction of people, even the intellectuals, is that of fear. I have friends who would turn their heads, cover their ears, if we start talking about nuclear. Why is that so? Many reasons is mainly because it is associated with nuclear bombs. You must remember, perhaps, Nagasaki and Hiroshima and the horrors created to humanity. I visited Hiroshima last year, and even if it has grown back, you can really see the horrors. More recently, we have had nuclear accidents in power plants. You have heard a lot about Chernobyl. There's a series on it. And most recently, in 2011, Fukushima. But above all, there is really lack of adequate and balanced information on nuclear. Lack of education on nuclear. And so that's why it becomes very mysterious. The mystery is even what makes it exciting. Next slide, please. So why do we need to demystify? It's mysterious, but why do we need to demystify? Because in reality, there are many useful applications of nuclear science and technology. And nuclear, anyway, is around us even as we speak. Radiation is around us even as we speak. We have the sun, and so on and so forth. There are many useful nuclear technologies in our daily lives, in health, in agriculture, in environment, climate change, etc. Name it. So we need to transform that fear that really constricts us, humanity, transform it into knowledge, know more about it, in order to raise competence and confidence for a very useful technology. And hopefully excite for an overall interest in science, technology, engineering, and math. Because nuclear is one component of science and technology. And I think even if one does not become a nuclear scientist or nuclear engineer, as what 𝐏𝐀𝐚𝐬𝐿 has mentioned a while ago, it's a lifelong learning. We need to know what we are, where we are living in, the environment that we live in, the earth, the planet, the atoms that are very, very tiny beyond our human visibility, but which makes up the whole of where we live in and ourselves. Next slide, please. So radiation technologies touch our lives. Nuclear technologies, radiation technologies touch our everyday life. Here is just a collage of pictures just to show you very ordinary pictures, cables, instruments, tools in hospitals, cars, etc. All of these have been touched by nuclear technologies. And next slide, please. And different processes, our environment, sediment transport, dams, pollution, agriculture, oil processing, mining technologies, etc. These are all involving nuclear technologies. Next slide, please. And in fact, if we look at Japan, we know a very industrialized country. My slide just is a little bit dated 2002 from a publication. We can see that 85% of their radiation applications is related to industrial applications. So industrial applications generate a lot of socioeconomic impacts, a lot of contribution to the economy of a country. It's just one example. Next slide, please. Now I have here the late Yukiya Amano. He was an IAEA Director General, the #1 leader in the IAEA in his time. And he visited the Philippines. He visited the schools, 2 pilot schools that we used in our program as a pilot school for introducing nuclear science and technology. This was in San Francisco del Monte High School near Schumart in EDSA. And the other one is Manila Science. He said, science is one of the cornerstones of economic progress. And without technological advancement, human development goals are much harder to achieve. Nuclear science and technology is very much embodied and embedded into this statement. Next slide, please. So today, I will speak about non-power applications of nuclear technologies. I will not speak about nuclear power because so much has been written about it. I think in our newspapers in the past year or so, we always see or read about the Bataan nuclear power plant, some histories about it. To me, it's not a power plant, but it's Bataan nuclear power infrastructure because it's not generating. But there are many, many applications of nuclear technologies that I'd like to focus on today. Primarily considering the 17 Sustainable Development Goals. These 17 Sustainable Development Goals was formulated by many, many countries of the UN, over nearly 200, in 2015, to really collectively have a goal about reducing poverty by 2030, yes, and for each goal, dealing with food, agriculture, health, to make sure that by 2030, humanity is prosperous and there's an equal distribution, basically, of wealth. It's a very lofty goal. In 17 of these, in 9 of the 17 Sustainable Development Goals, you have a very clear and good application of nuclear science and technology. 9 out of 17 goals. From the goal to end poverty down to the goal related to life below water, goal 14, and so on and so forth. And nuclear technologies have been proven to have a clear socioeconomic impact. The other part of my talk, I'll end my talk towards the IAEA work with the young generation. And I see it a very good opportunity today to be addressing this topic because I see a lot of the youth in the room. Next slide, please. Let me deviate a little bit with my journey with isotopes, with nuclear technologies. I was introduced, I'm a geologist, And when I was working in the Philippines for 13 years before I moved to Vienna, so soon after graduation, I worked for the National Environmental Protection Council, where I was in environmental impact assessment, looking at the implication of any development issue in the environment. During that time, we encountered in the office the problem of groundwater salinity in the country. And the only way to understand the source of groundwater salinity is through stable isotopes, in addition to the chemical content of water. We needed to understand, where is salinity coming from? Is it due to recent seawater intrusion because of obstruction of groundwater? Or is it due to old groundwater that has been trapped in the sediments for many years? Why do we need to know it? Because there are two different extreme implications to management and development for this groundwater, either to drill or not to drill. Subsequently, because of further training, I moved to geothermal hydrology and geochemistry, where I moved to the Energy Development Corporation for geothermal exploration and development. I continued to use stable isotopes for really understanding the dynamics, processes, and flow of very hot fluids in order to have an input, a geochemical input to the understanding of the area where we were exploring in order to drill a well. To drill a well of, at that time, 30 years ago, would cost about $1 million per meter. So you see the strong importance of science and technology in understanding the system in order to make a good decision. Next slide, please. One of the important applications of nuclear technology using naturally occurring elements, stable, non-radioactive, and radioactive elements that occur in nature, is understanding the hydrological cycle. We have evaporation of waters coming from the ocean, from land. They are transpired, and then, of course, the vapor is transported. They become rainfall, precipitation. If the rainfall is sufficient enough, they can recharge what we call aquifers. These are systems, rocks, areas, sediments that can store water that can eventually be abstracted for our use. If we look closely at the picture, every step, every process has a different isotopic signature. So numbers are quite tiny, but from -25 to -11 on that side, and it differs as we go deeper into the system, which means we will be able to trace what is happening within a hydrological cycle and have an understanding of our environment, have an understanding of where water flows, how it flows, and where we can develop our groundwater systems properly in order to be sustainable. Next slide, please. So in the 60s, the Philippines was already collecting some rainwater samples in order to have an understanding of the hydrological cycle within the Philippines. That was not a very thorough work. And in the 60s, early 60s, this data has been part of the global isotopic work, which was done with the International Atomic Energy Agency. And then subsequently, in mid-80s, I was involved in this work. Together with the IAEA, and at the time the National Environmental Protection Council, we did some work in order to understand better the sources of groundwater salinity. But I moved to the oil company, and in the late 80s, we continued with really the determination of the different isotopic signatures across the different areas in the Philippines. Next slide, please. So here, I will not discuss the science, but just to show you how important isotopes are. In water, we drink water, H2O. We think it's just hydrogen and oxygen. But there is actually an isotope there, oxygen 18, which is not common, and deuterium, which is also not common, instead of just the hydrogen. And these are the isotopes that we use in order to understand the different processes. Even these isotopes can tell us, for example, the composition of our blood, where it comes from, or wine, where wine comes from, etc. So, how strong isotopic data nuclear technologies are, it can tell us where rain comes from during the different months. In this area, I was able to say it comes from the northeast, it comes from the southwest. On that graph, I can say, or we can say, that the composition in the southern part of the Philippines is different from the northern part of the Philippines, from Mount Apo to Bacon Benito in Bicol and the Metro Manila, etc. Next slide, please. Because of that, we will be able to conceptualize how the water flows within the system, and then we can say, we can drill here, we don't need to drill there, we have to protect this area, etc. Of course, it's not only due to stable isotopes. You have also the inputs of chemistry, of physics, of engineering, etc. So this is how strong nuclear technologies in determining the processes in the water resources management. Next slide, please. How strong is it, or how important it is? This has been sampled. The work for the geothermal systems has been done in many areas of the world. This was in 1999, and the red areas indicate where our work at that time was being done for stable isotopes, isotopic nuclear technologies in many geothermal areas worldwide. Next slide, please. Now, that's one application of nuclear technologies. The second is what we call non-destructive testing. This is when we can improve manufacturing controls and reduce production costs in different industries like aerospace, shipping industry, manufacturing industry, oil and gas, basically using nuclear technologies in order to, for example, understand or determine where the flaws are in certain pipelines, as an example. So because of that, you don't need to have an obstruction in the operation of a manufacturing process. And as a result, there can be 5 to 10% decrease in production cost, or you can have 10 to 20% reduction in time for inspections, because you don't need to stop the entire operation. You can use nuclear technologies or nuclear instruments in order to determine different flows or processes within a manufacturing flow. In the Philippines, the number of, I think, inspectors or groups dealing with NDT, non-destructive testing, has risen in the last 10 years, which means it's being used quite extensively. Perhaps in many cases, it's not known to a layman or to the public that, yes, These are very useful tools. These are nuclear technologies that are used in industries. Next slide, please. This is an example in Malaysia, and similar to what we do here. Sectors where non-destructive testing is performed in oil and gas, in chemical, petrochemical industry, in automobile industry, aviation, power generation, construction, manufacturing. And many countries are using this, whether they are advanced economies or even least developing countries also use these technologies. Next slide, please. The other very important application is in agriculture, in food and agriculture. It improves crop and plant varieties through induced mutation breeding. What does this mean? You can have different varieties of crops developed within a short period of time through mutation breeding. And these are crops that can be resilient to climate changes, to harsh environments. They can produce more yield. They're resistant to diseases. And the other application of nuclear technologies is on livestock reproduction and nutrition, in order to ensure that the animals have better nutrition, good yield. Thank you. The third one is the control of animal and plant pests and diseases through what we call sterile insect technique. This is using radiation in order to sterilize the insects, like mosquitoes, there's some like medfly, that which affects the fruit, which is more environmentally acceptable rather than using pesticides and sprays. And this can have a very economic value to the production of fruits. The other is better soil and water management. Some crops there has to be investigations how much nutrition, how much fertilizer is needed by crops. And this can be studied using isotopes to trace the movements of the water and or nutrients or fertilizers into the plants. And lastly, the improving food safety. Particularly nowadays, there's a lot of the use of pesticides and or veterinary chemicals. So it's important to have good food safety monitoring, especially if there is trade from one country to the other, to ensure that your food that you consume or you import is of acceptable quality. You also use nuclear techniques for such instances in the laboratory. Now, what I'd like to show there is in many cases, the yield for crops that have been produced through mutation breeding using radiation technology can be by as much as 33% increase in yield. Next slide, please. I think this is a very important example, improving rice production, which is an example in Vietnam. And in this case, the results of their work using irrigation technology is a shorter maturity for rice, meaning they can have 3 harvests per year instead of normally 2 harvests per year, because the rice can be very productive within a short period of time. They're more tolerant to flooding, especially in the Mekong Delta. They're tolerant to salt, and they're less prone to diseases. Next slide, please. The good news is, first, we have also very good example about a success story for mutant cotton in Pakistan, and also different results of radiation processing in Thailand. There's several examples of this kind, but the good news that I'd like to jump onto is in the Philippines. The next slide, please. Next slide, please. The Philippines turning seaweed into a plant growth promoter. Perhaps you know that the Philippines is the major or the top producer of carrageenan found in seaweed. Our scientist here, Dr. Lucille Abad of the Philippine Nuclear Research Institute, has really succeeded in researching, determining, and using carrageenan, which is found in seaweed, to improve the production of rice. Rice crops here sprayed with carrageenan withstood a devastating typhoon, while nearby rice fields without carrageenan experience lodging. You can see the difference, I hope, in the crops, those with carrageenan and those without carrageenan. I know that this product has been rolled out in some areas, but perhaps there is a need to roll out to more areas for greater use. I think it's only in some areas that it is now being used. Now, there are many important successes about such stories in this publication that we have released in the IAA while I was still directorate. And these are stories of the successes of different countries from Afghanistan to Yemen in different applications of nuclear technology. Now I go to the other application, which is on human health. Next slide, please. Next slide, please. So here, radiation technology, particularly in radiation medicine, is used for quality diagnosis and treatment of cancer, which continues to be a major human health challenge globally. And we have our experts here in human health. According to the data of WHO some time ago, 10 million lives every year globally is affected by cancer. But I'm sure many of us have encountered nuclear technologies. Each one of us has had at least an X-ray. This is also part of nuclear technology. But yet, we are not afraid to have X-rays because we know it's essential for our health and well-being. Next slide, please. So if we have to roughly summarize, what are the socio-economic impacts from the application of nuclear technologies in some sectors? In mutation breeding, I mentioned a while ago, you can have resilient crops, whether during drought and or flooding. We have a lot of impacts of climate change these days, but you can produce, it's possible to produce resilient crops for these very harsh climate environments. In many cases, up to 50% more yield with less time for growth. Okay? You can have a year-round farming instead of just once or twice a year. The other part is post-harvest losses through irradiation. Some years ago, we have heard on television that our farmers are losing about a third of their crops, rice yield, because they are rotten, they cannot be transported over long distances. Some of their products, some of their crops cannot be stored for a long period, short shelf life. But there are solutions to that. through irradiation. And irradiation is a technology that has been used for many, many years and found safe. Even developed countries have been using it. And therefore, their export and even local consumption of crops are much better. Here, if we have a farmer who loses a third of his produce, that means a huge economic loss. We need the technology, which has been proven for many years, to be used to help our own local food production. Not only does irrigation technology increases the shelf life or prevent post-harvest losses, but it also decreases the use of chemicals and preservatives, which are, of course, concerned environmentally. For food safety, I mentioned that a while ago, early detection, instead of 4 weeks, you can have a quick and early detection of the presence of certain contaminants in food through nuclear technology in different laboratory methods. Therefore, you can have good exports of fruits or product and good quality control. Even for determining the absorption of vitamins and minerals, nutrients in lactating mothers and our children, stable isotopes are also used. So there are many, many applications that have to be better explored, understood, and used. Next slide, please. Nowadays, there are 3 very important problems that we are facing globally. One is climate change. Second is plastic pollution, of which the Philippines is on top of the list of heavy plastic pollution in land and in the sea. And third is the zoonosis, so that's why we have had COVID. It is said that by 2050, there will be more plastics in the ocean than fishes. So what do we do about it? There are nuclear technology methods. One is to monitor the occurrence, the distribution, and the movements of microplastics in the ocean. Why do we want to know where they are accumulating and where they are being transported so that solutions can be found? The other part is to transform this plastic waste into something that is more useful. Next slide, please. The IAEA has launched in 2021 a major project related to plastic monitoring and irrigation of plastic for another use, for better use, for use of the materials. And the Philippines is leading in it, and I think it's a very good news for all of us here. The first is to enhance global understanding for the abundance and impact of marine plastic pollution. There will be a network of some 50 laboratories worldwide. The Philippines is part of them, in order to monitor, determine, and project where microplastics are moving. The second is to enhance plastic recycling to complement conventional practices and production of sustainable alternatives to petroleum-based plastics through the application of radiation techniques. Right now, the Philippines, together with 2 other countries, Indonesia and Malaysia, and I think Thailand too, are moving in a very good pace with respect to the use of irradiation for plastics, to transform the plastic waste into something more robust, solid, stronger, up to the use of these materials, recycled plastic materials, as construction materials for houses, Right now, they're using it for chairs anyway and tables, but the ambition is even to go beyond that. And you can just imagine we have so many plastic wastes that can be transformed through radiation technology. Of course, it's a big process that is ongoing now, but if you like to imagine how it is, there is what we call technical readiness level 1 to 7, and our researchers here at the Philippine Nuclear Research Institute is moving to TRL 5, which means a very good progress after 2 years. And then some pilot plans can be developed. Next slide, please. And there are many other applications, exotic also, criminal investigation, identifying the fraud, the origin of, let's say, in paintings, archaeological artifacts, preservation of these things, and so on and so forth. Next slide, please. Which means it is very, very interesting to understand what nuclear technologies are and how can they really be useful in our lives. Either they are so simple or so sophisticated, but many things can be learned. Next slide, please. So if I go back to the Sustainable Development Goals, the target is by 2030, these goals would have been achieved. This is a report from ESCAP of 2022 for Asia and the Pacific. Asia and the Pacific constitutes roughly about 60% of the population in the world, which means to say whatever happens in Asia and the Pacific really affects the global scenario. So if you look at that slide, we are far away, Asia-Pacific, Philippines being part of Asia-Pacific, we are very far away from achieving the target of 2030. What does it mean? A lot of scientific work has to be done to find solutions. Here we have a lot of young generation. Even the old generation can continue learning as we do. Lifelong learning, so to speak. So there's a big challenge, but a big opportunity to exert effort, to be interested in science, in technologies, and be open to the different options. Next slide, please. Because human resource is the strategic enabler for any development, for any solution, for any action. And this is where we need our young generation. We need to have both men and women, graduates, studying different disciplines in order to have a contribution to the different solutions. Because while nuclear technology is very focused and a very critical technology, a very useful one, you need also to have a multidisciplinary approach. Next slide, please. When we launched this program in 2018, in order to introduce nuclear science and technology to the young generation in secondary schools, primarily, especially to demystify, for all of those reasons that I have mentioned, we targeted 1 million students as beneficiaries in 4 years. That was very ambitious. We were not, many people were not sure if it can be achieved. And ladies and gentlemen, I'm happy to tell you that it was achieved even ahead of schedule. We reached 1.6 billion ahead of schedule. Why am I saying this? Because many things sometimes they can be impossible to be achieved, but if people work together, if we enhance the education of the youth, then many things can change, can be reached. And what we did here is to train the teachers, empower the teachers through classroom activities and or extracurricular activities, and the teacher teaches 30 to 50 students in a classroom. Next slide, please. But that was for 17 countries in Asia and the Pacific, including the Philippines. Here, I projected this slide to emphasize the need for a multidisciplinary discipline, for a different discipline in dealing with anything, including nuclear power generation, including for agricultural development, including for industrial development. If we look at the disciplines here, you have management, funding, financing, legal, safeguards, regulatory framework, electrical grid. This means a lot of need for highly competent professionals in engineering, in mathematics, in finance, in law, etc. So in nuclear science and technology, you need to have very good training, which can, of course, be achieved because there are many opportunities. And next slide, please. And I'd like to show you the International Atomic Energy Agency, the international organization of about 180 member states, which was founded in 1957. I'm very fortunate to have worked with the IAEA for 30 years in a very good career, starting as a geologist until I moved to leadership position as Director for Asia and the Pacific Technical Cooperation. The objective of the IAEA is to accelerate and enlarge the contribution of atomic energy to peace, health, and prosperity throughout the world. And with this mandate, you have had a glimpse of why there are many applications of nuclear technologies in our daily lives. Next slide, please. So, I hope I have given to you some glimpse of the different nuclear science and technologies that have really socio-economic impacts. But it is important that these nuclear science and technologies do not remain in laboratories. They have to be rolled out, used in the different sectors, applied. But they cannot be applied if there's fear. So that's why you need to have education and proper information. Education is important at various levels. We were saying in those days when we introduced nuclear science and technology that we can say, oh, nuclear is good. You have to have the full knowledge. The young generation has to understand why it is good in order for the young generation to have a good judgment whether it's good or not. And if it is not, why? If it is good, why? Next slide, please. I think that this is my last slide. If we look at the Philippines, around 30% or 28% of our population is the young generation, about 10 to 24 years old. I think the majority of us here in the room is in this category. They are the leaders, you are the leaders of the future. That's about 30 million young people, 30 million. We know our standing in science and in technology needs to be improved. The question we have is, how could graduates in science and technology be increased for Philippine development? We have a very ambitious developmental program, which is very important for our country. How can graduates in science and technology be increased? We hope nuclear science can ignite, can catalyze this interest for science, technology, engineering, and math, which are needed for development. If we look at the different developed countries, the ratio of STEM graduates is much, much higher than ours. Even countries in Asia, our neighboring countries. What can be done for the young Filipinos, who constitutes a third of our population? We need to ignite the interests of the youth. I've spoken with several leaders. It's important to start young. We need to empower the educators. Even teaching nuclear science and technology, we need to teach the educators. And you have seen how the cascade effect has been very efficient and effective. We need to propagate the knowledge because time is running out. Aim for an ambitious target. And here, we have an opportunity, whether we're Pamana awardee and or retirees, ordinary citizens, young people, we have the privilege to make an impact. But not only a privilege, it's also our responsibility to leave a good legacy for the future generation. So I hope, ladies and gentlemen, your interest has been ignited and a little bit unraveled, a little thin layer of the onion to demystify what is nuclear science and technology. Thank you.